about the next questions of the problem set 5 of the chapter Coordinate Geometry Mathematics Part 2 10 standard. The question number 9 is, find K if the line passing through P minus 12 minus 3 and Q 4K has slope is 1/2. Its solution is, so simple question. Here is P having coordinates minus 12 minus 3, Q having coordinates 4K, slope is denoted by M is equals to 1/2. Let the coordinate of P be x1 y1 and Q be x2 y2. Then x1 is equals to minus 12, y1 is equals to minus 3, x2 is equals to 4 and y2 is equals to k. Therefore, we know that the formula slope of line denoted by M is equals to y2 minus y1 upon x2 minus x1. This slope is given 1/2, so that 1/2 is equals to y2 is here k minus y1 is minus 3 and x2 is 4 minus x1 is minus 12. Then 1/2 is equals to, this is k plus 3 upon 4 plus 12. Minus minus plus. Then student, this is 1/2 is equals to k plus 3 upon 4 plus 12 becomes how much? 16. Then by cross multiplication we write here 16 upon 2 is equals to k plus 3. Only this 16 transposed to this side. Then when we simplify it, it becomes 8 is equals to k plus 3. Again transpose this 3 to this another side, convert as minus is equals to k. Mean that this is 5 is equals to k. Therefore k is equals to 5. Then the answer in full sentence. Therefore the value of k is 5. Okay, we take the next question. Question number 10. Show that the line joining the points 4, 8, B, 5, 5 is parallel to the line joining the points C, 2, 4 and D is 1 and 7. Student, we know that if the slopes are equal, then the lines are parallel. Mean that you have to show here this slope AB is equals to slope of CD, then these two lines are parallel. For this, its solution is, so simple question. A having coordinate is 4, 8, B having coordinate is 5, 5, C having coordinate is 2, 4 and D having coordinate is 1 and 7. Student, all of you know that slope of any line is equals to, formula is y2 minus y1 upon x2 minus x1. We have to find out the slope of this line AB is equals to, look carefully, I will directly use here x1 y1 x2 y2, then y2 is 5 minus y1 is 8, x2 is 5 minus y1 is 4. Then this value becomes minus 3 upon plus 1, mean that the slope is minus 3. Then we have to find out the slope of other line, mean that slope of line C is equals to, again we use this formula. Consider x1 y1 x2 y2. At that time y2 is 7 minus 4 upon 1 minus 2. Then this subtraction becomes 7 minus 4 becomes 3 upon minus 1. Mean that this slope is equals to minus 3. Therefore, slope of line AB is equals to slope of line CD. Therefore, we know that parallel lines having equal slope, lines have equal slope. Therefore, these two line segments are parallel. Therefore, line AB is parallel with line CD. Now we have to show that the line joining the segment is parallel to the line joining the other points here. Therefore, the answer is Therefore, the line joining the points A in bracket 4, 8, B 5, 5 and is parallel to the line joining the points C 2, 4 and D 1 and 6. Okay, we take next question. Question number 11. Show that point P 1 and minus 2, Q 5, 2 are 3, minus 1, yes, minus 1, minus 5 are the vertices of parallelogram. For this student, we have to show that these two opposite sides are equal, means the distance of any two sides are equal. Then the quadrilateral is parallel. For this, its solution is, here is P having coordinate is 1, minus 2, Q having coordinate is 5, 2, R having coordinate is 3, minus 1 and S having coordinate is minus 1, minus 1. Therefore, by using distance formula, I have to write the formula for any one segment. Suppose that segment PQ, distance of segment PQ is equals to in root of, here is take x2 minus x1 bracket square plus y2 minus y1 bracket square. Student, we use this formula to find out the distance of this segment PQ. Here is x1 y1 x2 y2. When we substitute here, x2 is 5 minus x1 is 1 bracket square plus y2 is 2 minus 2 bracket square. Then this value become 5 minus 1 means 4 square plus this is 2 plus 2 become 4 square again. Means that 4 square plus 4 square is equals to root of 16 plus 16, means that root of 32. Again we factorize it, 16 2s are, therefore PQ is equals to how much? 4 root 2. This is the value of PQ. Suppose that this is equation number first. Student, then we have to find out the value of QR here. So QR is equals to, directly use this formula, distance formula for finding out the value of QR, taking x1, y1, x2, y2. Then x2 is 3 minus x1 is 5 bracket square plus minus 1 minus 2 bracket square. This value becomes minus 2 square plus this one becomes minus 3 square. Minus 2 square is 4 minus 3 square is 9. The addition becomes root of 13. This is the value of QR. Suppose that this is equation number 2. Then we have to find out the third distance is RS by using again distance formula. Use x1, y1, x2, y2. At that time x2 is minus 1 minus 3 bracket square plus y2 is minus 5 minus 1 bracket square. Then this value become, here is minus 4 square plus 5 minus plus this minus 5 and minus plus 1 square. Then this value becomes minus 4 square plus this is also minus 4 square is equals to root of 16 plus 16 is equals to root of 32. I have to again factorize this, root of 32 is 16 into 2. Then RS is equals to 4 root 2. Suppose that this is equation number 3. Then PS. Again we use this formula in this is x1, y1, x2, y2. Then minus 1 bracket square plus y2 is minus 5 minus 2 bracket square. This value become square plus this is minus 5 minus minus plus 2 bracket square. This value become minus 2 square plus minus 3 square. Then this is minus 2 square is 4 plus minus 3 square is 9. This addition is in that PS is equals to root of 30. Suppose this is equation number 4. Observe carefully student, equation first is 4 root 2, equation third is 4 root 2. So from this equation first and third I have to write here PQ is equals to how much? RS. Reason is from equation first and third. Then observe second and fourth, root of 30 means that QR is equals to PS from equation second and fourth. Means student, in a quadrilateral PQRS, PQ is opposite to RS. Here is QR is also opposite to PS. So therefore opposite sides of quadrilateral are equal, that is congruent. Therefore this quadrilateral PQRS is parallelogram. And we have to show that all these vertices are the vertices of parallelogram. Therefore answer in full sentence. Answer: P having coordinates 1 minus 2, Q having coordinates 5 2, R having coordinates 2 minus 1, 3 minus 1, S having coordinates minus 1 minus 5 are the vertices of parallelogram. Can you understand this? Okay, we take the next question. Number 12. Show that the quadrilateral PQRS formed by the vertices P 2 and 1, Q minus 1 3, R minus 5 minus 3, and yes, minus 2 minus 5 is a rectangle. Now for this student, we use the distance formula. First we have to show that the opposite sides are equal. If opposite sides are equal, then this is quadrilateral. This quadrilateral is parallelogram. And if in parallelogram the diagonals are equal or congruent, then it is a rectangle. So we have to find out 4 sides also and the 2 diagonals also. Then we conclude this is a rectangle or not. Okay. Now for this, its solution is so simple. Look carefully. Here is P having coordinates 2 1, Q having coordinates minus 1 3, R having coordinates minus 5 minus 3, and S having coordinates minus 2 minus 5. Now student, first I will write here by using distance formula. Student, the distance formula is, for I have taken any one segment PQ is equals to in root of x2 minus x1 bracket square plus y2 minus y1 bracket square. We used to find out all these segments, the distance between any two points by using this formula. Therefore, first I will find out the formula for, use the formula for segment PQ. The distance of PQ by using x1, y1, x2, y2 is, the formula is x2 minus x1, means that this is x1, y1, x2, y2, then minus 1 minus 2 bracket square plus y2 is 3 minus 1 bracket square. Now this distance is equals to, this is minus 3 square plus this is 2 square. Student, this minus 3 square is plus 9 plus 4. This becomes root of how much? 30. This is equation number first. This is the value of PQ. Then we have to find out the value of QR. QR is equals to, again we use this distance formula for finding this distance of QR. It is x1, y1, x2, y2. Then x2 is minus 5 minus here is x1 is minus 1 bracket square plus here is y2 is minus 3 minus again y1 is minus 3 bracket square. Then student, this value become minus 5 minus minus plus 1 bracket square plus this is minus 6 square. Student, minus 5 plus 1 is minus 4 plus here is minus 6 square. Minus 4 square is plus 16 plus 36. The addition becomes here is 6 6 2 12 that is 1 4 plus 5. Again we have to factorize it 13 4s are. So that the value of QR is equals to 2 root of 13. This is equation number 2. Next student, we have to find out RES. RES is equals to in root of taking here x1 y1 x2 y2. At that time I have to write here in big bracket. Here is minus 2 minus minus 5 bracket square plus in another bracket here is minus 5 minus minus 3 bracket square. Then this is minus 2 plus 5 bracket square plus this is minus 5 plus 3 bracket square. Then this value becomes here is plus 3 square plus minus 2 square. This is 9 plus 4. This is root of 30. Now therefore RES is equals to root of 30. Equation number 3. Then we have to find out the equation PS. By using distance formula, again use this formula x2 minus x1 plus y2 minus y1 bracket square. For this PS x1 y1 x2 y2. Then this value becomes x2 is minus 2 minus 2 bracket square plus y2 is minus 5 minus 1 bracket square. This value become here is minus 4 bracket square plus this is minus 6 bracket square. Then I have to take this square here. Minus 4 square is 16 plus this is 36. Again this value becomes 52. Then PS is equals to, I have to again factorize it, 13 into 4 is equals to 2 root of 30. Equation number 4. Student, observe carefully equation first and third. These two segments are equal, root of 30. Therefore these two are also equal. Therefore from first and third, PQ is equals to RES. From equation first and third. And also when we look here second to root 3 and fourth to root 13, sorry, to root 13 to root 13. Therefore QR is equals to PS from equation second and fourth. Student, opposite sides are equal, therefore this quadrilateral PQRS is parallelogram. Then I have to find its length of diagonal. Now here in this quadrilateral PQRS, PR is the diagonal, so I have to find out this PR by using distance formula. Again we use this distance formula. PR, take x1 y1, this is x2 y2. Then I have to write here x2 is minus 5 minus x1 is 2 bracket square plus y2 is minus 3. Then this is minus 1 bracket square. Student, look carefully. this is minus 7 bracket square plus this is minus 4 bracket square. This one is minus 7 square is 49 plus 16. Therefore, PR is equals to, this is root of 5, 9 plus 6 become 15, 1, 6 here, mean that suppose that equation number suppose 5. Then we have to find out next diagonal is QS. Again by using distance formula we use this formula here. For this x1 y1 x2 y2, then it becomes x2 is minus 2 minus 1 bracket square plus here is y2 is minus 5 minus 3 bracket square. Then student, this is minus 2 plus 1 bracket square plus minus 8 bracket square. This value become minus 1 square plus minus 8 square is equals to minus 1 square is 1 plus 64. Means that QS is equals to root of 65. 6 ones. Okay, from 5 and 6 we conclude that PR is equals to QS from 5 and 6. Now student, mean that in parallelogram, they put in parallelogram PQRS, the diagonals are equal. Therefore, this quadrilateral PQRS is rectangle. We have to show that these are the vertices of the rectangle. So you have to write the answer in full sentence. Look here, you have to write the answer in full sentence. Answer is that therefore P21 Q minus 1 3 R minus 5 minus 3 and yes minus 2